In this video, we're going to be taking a look at how to make a stem and leaf plot. Which is sometimes referred to as a stem and leaf display. And stem and leaf displays, let me kind of show you what one might look like here really quickly. Say we have 0, 1, 2, 3, and 4. And then there'll be a vertical line here, and then there'd be like, 1, 2, 3, 3, 5, 2, 3, 7, 8, 8, 9, for example. 2, 4, 4, 4, 4, 5, 6, 9, 0, 0, 1, 2, 5, 5, 8, and maybe, and let's say there's nothing on the line with the 4, and then there's 5, 1, 2, 3, 3, 3. Okay, so let's say this is what we had for our stem and leaf plot. And maybe this is representative of dollars, and we have something off to the side here that says 2 vertical bar 1 equals $21. Okay, so there are two essential pieces of the stem and leaf plot. This part is the stem and leaf plot itself. This part is what's called the legend, and this essentially tells you how to interpret the stem and leaf plot. It tells you the place value of what you're looking at. And basically what a stem and leaf plot does is it's a compact way of representing a larger set of data. So here we have a bunch of values that are all attached to what's called a stem of 0. These values on the left-hand side of the vertical bar are called the stem, and these values on the right-hand side are called the leaves. So what this is telling us is that we have one data point that has a stem of 0 and a leaf of 1. It's $1. We have another data point that has a stem of 0 and a leaf of 2. That would represent $2. 0, 3 would be $3. We have another 0, 3, and then a 0, 5 would be $5. When we drop down to the next line, we've now increased our stem to a 1. So this then is going to represent a stem of 1 with a leaf of 2. That's going to be $12. Stem of 1, leaf of 3, $13. Then 17, 18, 18, and 19. Okay. Then these would all be in the 20s, $22, 24, 24, and so on. 30, 30, 31, and so on. We don't have any in the $40 region because that line is blank. Then we have some in the 50s, 51, 52, and a few 53s. Okay, that's how to interpret a stem and leaf plot. Now, the key in making a stem and leaf plot is that the leaves are only ever one single digit long, and it will be the rightmost digit in your numbers. So in this case, because we were dealing with 2-digit numbers, the rightmost digit is the ones digit. So all of these were representing ones digits, which means that the stems were the tens digits. Okay. Couple of other things to keep in mind. Because the leaves are only ever 1 digit long, no separating mark needs to be made between the leaves. There's no commas, there's no vertical bars. You'll just leave a little bit of space in between each leaf. The stems should be listed in order from lowest to highest. The leaves should be listed in order from lowest to highest as we read from left to right. Repeated data values will show up as repeated leaves. And if there's a stem that doesn't have any leaves attached to it, if there's nothing in the 40s, for example, we leave that line blank. Resist the urge to put a 0 in there because that would mean that there was a data point at 40. Okay. So let me grab us a set of data and we'll take a look at putting one of these together. I'm actually borrowing this from one of the problems that's in the book that we're currently using. But basically this is looking at weights of carry-on luggage in pounds. And then here's the weights that we're given. 30, 27, 12, 42, 35, 47, 38, 36, 27, 35, 22, 17, 29, 3, 21, 0. I want to know how they did that. How did you get your carry-on luggage down to 0 pounds? But anyway, 0, 38, 32, 41, 33, 26, 45, 18, 43, 18, 32, 31, 32, 19, 21, 33, 31, 28, 29, 51, 12, 32, 18, 21, and 26. Okay, so there's all of our weights of the carry-on luggages that we're looking at in pounds. And then what we want to do is we want to make a stem and leaf plot out of this. So you'll notice that our data are 2-digit data. And the first thing that we need to figure out is what's going to constitute a stem and what's going to be a leaf. Since the data are 2 digits long, and since the leaves can only ever be the rightmost digit of the data, all of the ones values are going to be leaves, and all the tens digits are going to be stems. Then I essentially look for my lowest and highest data points. So my lowest data value is this value of 0, that's my minimum. My highest data value is, I believe, this value at 51. Let me just see if I see another one that's higher. No, 51 is our highest. Okay? So that tells me where my stems need to go from and to. This value, even though we don't see it, has a tens digit of 0, so its stem is 0. Then I've got a stem of 5. So I need stems from 0 to 5 to accommodate all of my data. Then we put a vertical bar here to separate the stems from the leaves. And then we're just going to go looking for what leaves are attached to this stem. Now, with the stem of 0, we're looking for any of our single digit data. So we have a 3, we had this 0. Was that it? I think that was it. Yes. So we want to put those leaves. We have a leaf of 0 and a leaf of 3. We want them in increasing order. So 0 and 3. Again, no separating marks between the leaves. We're just going to leave a little bit of space. So those are now done. Then I want my data that has stems of 1. So we've got a 12 here. We have a 17. We have an 18. A 19. Oh, here's another 18 that I missed. A 12, an 18, and I think that's it. Let me just do one more pass through here. Yep, that's it. So we want to put those leaves in here in numeric order. The first one would be a 10 if there were any, but there are no 10s. 11 would then be next. There are no 11s. But there's 2 12s. So I need 2 leaves of 2. There's no 13, 14, 15, 16. There is a 17. So I need a leaf of 7. There are 3 18s. So I need 3 8s. And then there's 1 19, so I need 1 9. Okay, so all of the ones digits that have a tens digit of 1, they're all grouped together on the same line. Then we're going to move on to the tens digit of 2. So we'll have a 27 there, 27 here, 22, 29, 21, 26, 21, 28, 29, 21, 26. So a lot of these. If there was a 20, we would put a 0 in here first, but there's no 20. So then we look for our 21s. Here's one of them. Here's another one. And another one. I think there were only the 3 21s. Yes. Then we move on to 22s. Here's one. Is that our only 22? Yes. No 23s, 24s, 25s. We do have some 26s. This one and this one. 27s, we have these two. I think those are our only 27s. Yes. And then we have a 28 and a 29. Okay. You'll also notice that as I'm writing these down, I've got things kind of aligned in columns. My leaves are being aligned in columns. We'll talk about why that's important in just a minute. So when you're doing these, make sure that your leaves, that space that you're leaving in between them, makes it so that they're lining up. Okay, then we go on to a stem of 3. So we've got a 30, 35, 38, 36 in the top row, 35 in the second row, okay, a lot of those. So, do we have a 30 this time? Yes, we do. So we have got a leaf of 0 there. Oh, crud, I missed a 29. There we go. So we've got 130. Then we look for 31s if we have any, which I think we do. Yeah, there's 1, 2 31s. Then we look for 32s. 1, 2, 3, 4. 1, 2, 3, 4. Then we look for 33s. 1, 2. Any 34s? I don't think so. 35s. 1, 2. 36. 37s. No. But I have 2 38s. Okay. Then 40s. We've got 42, 47 on top, 41, 45, 43, and that's it. So we have no 40s. We have a 41. We have a 42. We have a 43 over here. And then I think the 47 is our last one. Yep. And then for 50s, the only ones that we have there is the 51. So there would be our stem and leaf display for the weight of the carry-on luggage in pounds. But we do need a legend. Now, why do we need a legend? Well, because you sort of lose a sense of place value when you group all of your data into a stem and leaf display. It's possible that this one vertical bar 2 represents 12 pounds. It's also possible that it represents 1.2 pounds. And without a legend, we wouldn't know that. So you just put your vertical bar down here, and you can use any 2 values that you want. But just indicate what this arrangement would represent. If you had a 2 to the left of the vertical bar and a 1 to the right, that would represent 21 pounds. Okay, and you could have, again, used any of the pieces of data here to represent that. I was just picking the 21, but you could use 30, you could use, I don't know, 47, okay, but it's representing 21 pounds. And then in terms of why we need to make sure that our leaves are ending up in these columns, one of the things that people frequently wonder about with a stem and leaf plot is what advantage does it have? Why don't we just make a histogram? And for a very large set of data, you would just make a histogram. But the advantage that a stem and leaf plot has is it'll give us the same information that a histogram would, but we get to see the individual pieces of data. When we make a histogram, we lose the individual pieces of data. We can just see how many are in each category, but we don't see what they are anymore. In a stem and leaf display, we see all of the individual data values, and assuming that I've created it where everything lines up nicely, if I turn it on its side here, the heights of these, if I were to imagine superimposing bars on top of each of these, this would represent a histogram. So I can see that my most popular category is to have luggage that weighs in the 30 to 40 pound range. Okay, it is a unimodal distribution and it's roughly symmetric. So that's the idea with a stem and leaf plot. Your book does go over a couple of other interesting types of stem and leaf plots. One is a split stem and leaf. And basically in a split stem and leaf plot, if we go back to this data that we had here, we noticed that because there were so many pieces of luggage in the 30 to 40 pound range, we ended up with a really long line here. One of the things that you can do to avoid that is to create a split stem and leaf plot. Now I'm going to use the same data we were just looking at, but I'm going to create one of these split stem and leaf plots with it. So instead of having 0, 1, 2, 3, 4, 5, you're going to repeat your stems. 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, and 5. Then, on the first stem of 0, we're including any data values that had a leaf between 0 to 4. So we had luggage that weighed 0 pounds, luggage that weighed 3 pounds. On the next stem of 0, you would include any luggage that had a stem of 0 and a leaf of 5 to 9. Now we didn't have any 5 pound to 9 pound luggage, so this line is actually going to be blank in the split stem and leaf. Then when we drop down to the first stem of 1, any leaves that were attached to 1 that are between 0 and 4 get listed on this first line. So we had a 2 and a 2. And then any leaves from 5 to 9 get listed on the second line. So we had a 7, 8, 8, 8, 9. Then with our 2s, leaves from 0 to 4 on the first line. So we had a 1, 1, 1, 2. And then leaves from 5 to 9 on the second line. So 6, 6, 7, 7, 8, 9, 9. And then 3s, we're going to have 0, 1, 1, 2, 2, 2, 2, 3, 3 on the first line. And then 5, 5, 6, 8, 8 on the second line. Then in our 4s, we're going to have 1, 2, 3, and then second line 7. And then you'll notice here we're stopping with the first stem of 5. You certainly could put a second stem of 5 here, but the only value, the highest value that we had was a 51, so this line would be blank. And you would still include your legend that says, like 1 vertical bar 7 equals 17 pounds. But that's the idea of a split stem and leaf plot. It keeps your lines a little bit shorter if you have some categories that have a lot of data falling into them. The last kind of subtype of stem and leaf display that you should probably be aware of is what's called a back-to-back stem and leaf. And for this one, we're going to look at some archaeological data. We have two different archaeological sites, Site 1 and Site 2. And then what you'll see in a back-to-back stem and leaf is there'll be kind of this backbone that runs down the middle. So there'll be, in this one, we have a 2, 3, 4, 5, 6, 7, 8, 9, 10. And then let's say at Site 1, we had just a 5 here, and then a 5, 0, 5, 5, 5, 5, another 5, 0 line, 0, 5, 5, 5, 5, 5. And then we have, let's say 0, 0, 0, 5, 5, 0, 0, 5, 5, 5, 5, and 0. So let's say that's what we have for that site. Oops, let me move that up so you can see the bottom there. And then for Site 2, here's what we have. 0, 5, 5, 0, 0, 0, 0, 5, 5, 0, 0, 0, 5, 0, 0, 5, 5. And then we don't have anything for a bit. Then we have 0, 0, 5, 5, 5, 5, and 0, 0, 0, 0, 5. And then there'll be a legend attached to these two. The legend that's attached to this one says that 5 vertical bar 2 vertical bar 0 equals 25 centimeters at Site 1, 20 centimeters at Site 2. Okay, so what the heck is this thing and how do we interpret it? What a back-to-back stem and leaf display is used for is to compare two different distributions really easily because you're grouping two separate stem and leaf displays together into one stem and leaf display, where the stems are actually running down this middle column and the leaves are going out on either side. These leaves represent the leaves that are attached to our archaeological site number 1. And these are representative of depths where we found different artifacts. Then these are the leaves that are attached to site number 2. So what this is in fact telling you is that this first, the shallowest depth at Site 1 is a depth of 25 centimeters. We found an artifact at 25 centimeters there. At Site 2, we found artifacts at 20 centimeters, 25, and 25. Then here, with the stem of 3, we found artifacts at Site 1 at 30 centimeters and 35 centimeters. And then at Site 2, we found 4 artifacts at a depth of 30 centimeters and 2 at a depth of 35. Okay. One of the things that's really nice about the back-to-back stem and leaf is it makes it really easy to see differences between two distributions. So here, for example, I can see Site 1's distribution is unimodal and symmetric. Site 2 is bimodal with this big gap in the center. And one of the things that might make me wonder is what kinds of differences there were in the people who inhabited these two different sites. For example, it appears that this site tends to have been continuously inhabited because we see artifacts at all of these different depths. Whereas at Site 2, we have a bunch of shallow artifacts and then we have a bunch of pretty deep artifacts and nothing in between. That makes me think that maybe there was an older culture there that got sacked or conquered by some other culture, or maybe there was a natural disaster. Then there was some, pileup of, earth and debris on top of that culture's remains. And then there is a newer culture with shallower artifacts. And so that can tell us one of the main differences between the two sites. So that's one of the useful things about a back-to-back stem and leaf, is being able to compare multiple distributions relatively easily. Stem and leaf displays you will have to make by hand. There is no way to make them in the calculator, but for small data sets, they're relatively quick and easy to do by hand. If you find yourself dealing with an appreciably large data set, rather than making a stem and leaf display, the preferred method would be to make a histogram, and you would probably either do that on your calculator or in a computer program.